Hey guys, hope you're doing well. All right, so I just wanted to create a video going over this review of each of the problems. Remember, this is a YouTube link, so you guys can skip ahead, rewind, go to whatever problem. It might be throwing you off a little bit as you guys are going through and completing this review. All right, so you guys are going to be able to use that identity sheet for the sum and differences that I gave you on that first day. So make sure you, for the quiz on Monday, make sure you have that ready with you as well. I can post another one in that Google Classroom assignment to make sure you have it. All right, so for the first three problems, all we have to do is find the exact value of the expression using that identity. So I know the first day I went through and actually wrote out the ordered pairs and the quadrants that they're in. I'm not going to do that for the review. I'm really just going to kind of focus on the quadrants that each of these angles are in, but then also use that identity to plug in. All right, so first thing is, if you think about 5 pi over 6, you guys know you should be in quadrant 2 for that. 7 pi over 4, that one's going to be in quadrant number 4. So when we go to use our identity to actually find this value, we're going to have sine of 5 pi over 6 times cosine of 7 pi over 4 minus cosine of 5 pi over 6 times sine of 7 pi over 4. Okay, so once you guys have your identity written out with your angles plugged in, now you want to evaluate each of these. So sine of 5 pi over 6, we know that this is going to be a positive 1/2. Cosine of 7 pi over 4, this is going to be a positive root 2 over 2. Drop down my minus sign. Cosine of 5 pi over 6, that's going to be a negative root 3 over 2, since I'm in quadrant number 2. And then sine of 7 pi over 4, that's going to be a negative root 2 over 2, because we're in quadrant number 4. All right, now we're going to multiply each of these fractions together. So the left side is going to give us root 2 over 4, minus the right side ends up giving us a positive root 6 over 4. And now let's combine our numerators to get root 2 minus root 6 all over 4. When you guys are doing these first three problems, I guess this is true for all of them, but just really make sure that you're really focused on what quadrants each of these angles are in so that you get the signs right when you're going through and you're actually writing the numbers once you apply that trig function. All right, let's look at number 2, which is cosine. So I'm just going to have to erase some of the stuff for sine. All right, you know what? Maybe I'll be able to just zoom in a little bit more. Maybe that'll help. Okay. All right, so when we're looking at number 2, first thing you want to think about, just like we talked about in that first problem, is just think about what quadrant these two angles are in. So 4 pi over 3 is going to be in quadrant number 3, and pi over 4 ends up being in quadrant number 1. So when we use our difference of cosine identity, we're going to end up getting cosine of 4 pi over 3 times cosine of pi over 4 plus sine of 4 pi over 3 times sine, I don't know what just happened there, sorry, times sine of pi over 4. Okay, so cosine of 4 pi over 3, since we're in quadrant number 3, this is going to end up giving us a negative 1/2. Cosine of pi over 4 gives us a root 2 over 2. Drop down our plus sign. Sine of 4 pi over 3, that's going to give us a negative root 3 over 2. And then sine of pi over 4 gives us a positive root 2 over 2. So when we multiply these together, this is going to give me a negative root 2 over 4 plus negative root 6 over 4. So when we go to combine these, because our denominators are the same, we end up with negative root 2 minus root 6 all over 4. And that would be our final answer. All right, so let's look at number 3. So number 3, I know sometimes the tangent ones can be tougher because you do have a complex fraction, or not a complex, but you do have to multiply by the conjugate. So when you guys are focused on degrees, just make sure you know what ordered pairs you're working with, whether you're working especially with a 60 or 30 degrees and the ordered pairs that goes with that. So first thing is if we think about 120, we know we're in quadrant 2. And if we think about 225, we know we're in quadrant 3. Remember, 225 goes with a 45-degree angle, and 120 goes with a 60-degree angle. So using the sum of tangent identity, we end up with tangent of 120 degrees plus tangent of 225 degrees. And that's all over 1 minus tangent of 120 times tangent of 225. All right. One thing I should have stated before I went through and did this problem. No, it's really for the next one. Never mind. Sorry. Okay. All right. So once you guys have this, now you need to actually evaluate the tangents of 120s and 225 degrees. So we know tangent of 120. This is actually going to be a negative root 3. So we end up getting negative root 3 plus 1 over 1 minus and negative root 3 times 1. All right, so I like to rearrange the top to have the radical in the back. I just think it makes it look easier, especially when we go to FOIL. When you guys go to multiply the bottom, negative root 3 times 1 gives us a negative 3, but since there's a minus sign, it's going to turn into a positive, so it ends up being a 1 plus root 3. All right, so at this step, we need to get rid of the radical sign on the bottom, so here's where we're going to have to multiply by the conjugate. So you guys are going to take those two same exact terms on the bottom, but just flip the sign in between. And you're going to multiply that by the bottom and the top. And once you do this, remember, you're going to have to be able to FOIL to actually multiply these two things together. All right, so I'll do the next step in blue so it doesn't all kind of look like it's going together. When you guys are FOILing the denominator, remember your outside and your inside terms cancel. So all you have in your denominator is your first terms when you multiply them and your last terms when you multiply them. That's it. All right. The top, you're actually going to have to go through and FOIL and then add your two like terms in the middle. So my first terms are going to give me a 1. My outside terms give me a negative root 3, but my inside terms also give me a negative root 3. So those can combine together to give me a negative 2 root 3. And then my last terms, a negative root 3 times negative root 3, just end up giving me a positive 3. All right, once you're here, let's add our like terms on the numerator and the denominator. So we end up with 4 minus 2 root 3 all over negative 2. And then let's look to reduce. And since that denominator is negative, it actually also changes the sign of when you reduce up top. So we end up for our final answer getting negative 2 plus root 3. Okay, all right, so let's look at the next section of problems. I'll try to get there and show you guys the directions. All right, so for problems 4, 5, and 6, what you guys had to do is you had to find the exact value of the angle. Now, remember, we're using these identities really for this purpose because we try to find the exact values of angles that aren't special angles. So what we want to do is we want to break up a non-special angle into two special angles that we know how to work with. So if we have cosine of 195 degrees, what we can do is we can split this up using our special angles, and we can split this up into cosine of 150 degrees. Oh, hold on. Forgot my 0. So you can split this up into 150 degrees plus 45 degrees because we know 150 plus 45 give us that 195. And we know that both 150 and 45 are both special angles that we know how to work with. All right. So like I said before when we were doing these notes, there's a number of different ways that you guys can do this. You can try to do subtraction with it too. Most of the time you'll see me do like split them up using a sum, using an addition sign. But if you don't have the exact same two angles that I used, That's okay. As long as you go through and do the same work, you're going to end up getting the same answer I did, even if you didn't split it up into 150 and 45. All right, so now that we split it up this way, let's go ahead and actually use that cosine identity. So we're going to have cosine of 150 times cosine of 45 minus sine of 150 times sine of 45 degrees. All right, and now we actually want to go through and just apply and evaluate each of these trig functions to be able to replace them with a fraction. All right, so cosine of 150, we know we're working, well, you know what, let me put this up top too. All right, 150 we know is going to be in quadrant 2, and you're working with, in this case, a 30-degree angle. And 45 degrees is going to be in quadrant 1, and we're obviously working with a 45-degree angle. All right, so for cosine of 150, that's going to leave us with a negative root 3 over 2. Sine of 45 gives us a positive root 2 over 2. Minus sine of 150 degrees gives us a positive 1/2. And sine of 45 gives us a positive root 2 over 2. So when we go through and we go to multiply, we have a negative root 6 over 4 minus gives us a negative root 2 over 4. Then we actually go through and combine our numerators, and this is going to give us a negative root 6 minus root 2, and that's all over 4. And there's our final answer. All right, so let's look at a problem with radians. So let's look at number 5. So when you guys are looking at number 5, you have sine of 11 pi over 12. So we want to try to split these up in special angles that we know to work with. So what we could do in this case is we can take that 11 pi over 12 and think about how you could split it up and to get angles that reduce with 12. All right. So a lot of times you might be looking for numbers like 3, 4, 6, 2, even 9. Any of those numbers as your numerator will reduce with 12 on the bottom. So I'm going to split this up into 2 pi over 12 plus 9 pi over 12. All right. And the reason that we can do this is because we know each of them are going to reduce to a special angle. So the first one we know can reduce to pi over 6. And our second angle we know can reduce to 3 pi over 4. All right, so now if we use our sum of sine identity, we're going to have sine of pi over 6 times cosine of 3 pi over 4 plus cosine of pi over 6 times sine of 3 pi over 4. All right, now we're going to go ahead and replace each of those using our ordered pairs. So sine of pi over 6, all right, that's going to give us a positive root 3 over 2, since we know we're in quadrant 1. Cosine of 3 pi over 4, we know that's going to be negative since I'm in quadrant number 2, but that's going to be a root 2 over 2. Cosine of pi over 6, that's going to give us, oh, I'm sorry, I made a mistake already. This sine of pi over 6, I'm sorry. This should be 1/2. And it should be positive. I apologize. All right, cosine of pi over 6. Here's where root 3 over 2 is. And then sine of 3 pi over 4 ends up giving us a positive root 2 over 2. All right, so when we multiply these, we end up getting a negative root 2 over 4 plus root 6 over 4. So when we combine these, this is going to end up giving us a negative root 2 plus root 6 all over 4. All right, so last one we're going to work with on this type, and then we're going to actually start going to the ones that we did more so yesterday. Okay, so when you guys look at number 6, now we start working with tangent, and we have 285 degrees. So remember with tangent, there's something really important that you want to try to avoid. So you really, in this case, you want to avoid, since we're working in degrees, I guess I wrote it too high. It won't let me write it. All right, you want to really avoid a 30-degree angle. All right, never use a 30 degree, because what happens is when you take the tangent of 30 degrees, you end up getting root 3 over 3. And we don't want to deal with more fractions than we have to. So we really want to only stick with 60 degrees, and we want to stick with 45 degrees. Now, with that being said, if you're working in radians with tangent, make sure you avoid pi over 6, because pi over 6 is going to give you that same fraction, and we don't want to work with that. All right. So for degrees, avoid 30 degrees, and for radians, avoid pi over 6. Okay, so one way that we can look at 285 and split this up with not using 30 degrees, and we can split this up into tangent of 60 degrees plus 225 degrees. So when we go through and we use our identity, that means that we're going to plug all this stuff in. So we're going to have tangent of 60 degrees plus tangent of 225 degrees. And that's all going to be over 1 minus tangent of 60 times tangent of 225. All right, so when we go through and we start plugging in some values, now when we think about tangent of 60 degrees, remember 60 degrees is the ordered pair of 1/2 comma root 3 over 2. So the reason why we really want to stick with 60 degrees and not 30 degrees is, like we said, well, when we're doing tangent of 60 degrees and we put root 3 over 2 over 1/2, it just ends up giving us root 3. So we don't have an additional fraction that we need to work with. So we're going to have root 3 plus, we know tangents of 45 just gives us 1, over 1 minus root 3 times 1. All right, so when we go through, and kind of similar to number 3, I'm going to rearrange the top and multiply the bottom. We end up getting 1 plus root 3 over 1 minus root 3. So at this step, this is when we now want to multiply by the conjugate to get rid of that radical sign on the bottom. So we're going to take the same exact terms. We're just going to flip the sign in the middle and multiply it by the bottom and the top. All right. So once you guys do this, again, just like we talked about before, make sure you're foiling. On the bottom, your outside and your insides are going to cancel. On the top, nothing should cancel. You should end up actually adding some like terms in there. Same thing, I'll do this next step in blue. So when we take a look at our denominator, we should end up with just a 1 minus 3 because our outsides and insides will cancel. If we look at the top, our first terms gives us 1. Our outside gives us root 3, and our inside gives us root 3, so we can add those two like terms together to get 2 root 3. And then our last terms end up giving me a positive root 3. So when we add some like terms, the numerator should be a 4 plus 2 root 3 over negative 2. And then we look to reduce, and this one's going to switch the signs as well because our denominator was negative. So when we reduce, we end up getting a negative 2 minus root 3 is our final answer. Okay. All right, so last couple that we have to do. So for the last few, what we need to do is we have to evaluate the following given some important information to start. All right. Let me erase this. Sorry, I don't know why this keeps popping up. Okay. All right, so we're given the information that sine A is equal to a negative 4/5 in quadrant number 4, and that tangent B is equal to 12/5 in quadrant number, I just want to make sure that this is quadrant number 2. It's quadrant number 3. I think I scrolled over. Okay. All right, so the first thing you guys got to do is set up your right triangles to actually go through and get a picture of what this looks like so that you can find your missing x or y, whatever you need. So we think about a first. Since we know sine is -4/5 and we're in quadrant number 4, and sine is y over r, that means my y value needs to be -4. My r value needs to be a +5. And then if we go through and we use Pythagorean theorem, that'll help us find our x value. But if you guys are good with your right triangles, special right triangles, you know your x value is going to be 3. All right, if we look at our right triangle, which we'll call B in this case, that we're going through that second given information. If we're given that tangent is equal to 12 over 5, remember, tangent's really y over x. So when we draw this right triangle in quadrant number 3, what we're really saying is that y is 12 and x is 5. Now, since you're in quadrant 3, there's something really important you have to know. Both the 12 and the 5 have to both be negative. Now, when we're finding r, same thing. When we find r in this case, a special right triangle, r value should be 13. All right. And again, if you didn't know that, you could always use Pythagorean theorem, but it's going to give you your missing value that you need. Okay, so using that information, we're then able to answer the following 3 questions that follow. Let's see if I can hopefully keep that there. All right, for this one, try to zoom out so I can keep the pictures. Oh, that didn't work at all. Hold on. All right, I guess I'll just have to stay zoomed in. Okay. All right, so let's go over to problem number 7. I'll try to keep that picture in there best I can. All right, so for 7, I don't know why this keeps happening. All right, for number 7, you guys have to find cosine of A plus B. All right, so we know we're going to use our cosine identity. And we're going to go through and use those triangles that we just created for A and B to help us out. So when we go through and first use our identity, we're going to have cosine of A times cosine of B minus sine of A times sine of B. And A and B are obviously acting like our angles. So that's why we're using that A and B there. So when we look at cosine of A, remember, you're looking at the right triangle A that you set up. So since cosine is x over r, cosine of A is just 3 over 5. Cosine of B, then I look over here at my blue triangle, and I do x over r, so that's going to give me a -5 over 13. Drop down my minus sign. Then I have sine of A, so I go back and look at my red triangle, and it's y over r. And then sine of B, oh, I actually wrote an r, sorry. It should have been 5. And then sine of B is -12 over 13. All right, so now that you're here, we just want to multiply. So we're going to end up getting a -15 over 65. Drop down our minus sign. We get 4 times 12. That gives us 48. They're both negative, so it's going to turn into a positive. So it should be a positive 48 all over 65. Oh, why did I write 16 over here? Sorry, guys. That should be a 65. All right. Okay, now once we have these, now we're just going to actually go through, and since our denominator is the same, we can just subtract across the top. All right, so this should end up giving us a -63 all over 65. And that's our final answer. All right, so we're going to do the same exact thing with problem number 8. Now, number 8, you guys are just working with sine, so just be careful with the identity that you're going to use. But you're going to have sine of A times cosine of B plus cosine of B times sine of A. All right, so then if we look for sine of A, we're going to look at that red triangle. So that's going to give us y over r. Cosine of b, I'm going to look at the blue triangle. That gives us a negative 5 over 13. Oh my gosh, I'm sorry, guys. This is not cosine of b, and this is not sine of a. This should be cosine of a and sine of b. Sorry about that. All right, so cosine of a, if we look at our red triangle, is going to give us x over r, so we end up getting a 3 over 5. And then sine of b is y over r, so we get a negative 12 over 13. When we go to multiply them, this gives us a 20 over 65, plus this is going to give us a negative 36 over 65. We're going to add along the top, and it's going to give us a negative 16 over 65. Okay. All right, so sorry. So when I go through and actually move the screen, sometimes the triangles get really messed up. And sometimes the font just pops back in for no reason. I have no idea why. All right, let me fix this triangle really quick. All right, that was a negative 5, and I have no idea why this ordered pair is here. Okay. All right, so last one we're going to work with is cotangent of a minus b. All right, so remember when we were talking about this, when you start seeing cotangent or secant or cosecant, you want to treat them like the trig functions that they're reciprocals of. So for example, on number 9, we're going to treat this one exactly like tangent. But at the very end, we just have to make sure whatever we get for our final answer, we're just going to have to flip our final answer, and that's going to be our true final answer in order to get cotangent. All right, so when we think about tangent, and let me first rewrite the identity. But if we're thinking about tangent and it being a difference, we're going to have tangent of A minus tangent of B. And that's all over 1 plus tangent of A times tangent of B. All right, so when we start to plug things in, tangent of A is going to be y over x, so we have a negative 4/3. Tangent of B is y over x, so we're going to have a positive 5/12 because they're both negative. And that's all going to be over 1 plus negative 4/3 times a positive 5/12. Okay, so once you're here, now we want to actually, on the top, we're going to have to get a common denominator, and on the bottom, we're going to have to start to multiply. So with the top, this negative 4/3, if we need to get both denominators to be 12, we know that we can really turn this into a negative 16 over 12. So negative 16 over 12 minus 5 over 12 is going to give us our numerator of negative 21 over 12. If we look at our denominator, we're going to multiply these fractions together. We can drop our plus sign down, but we're multiplying a negative times a positive, so we know it's going to be a negative. And it ends up giving us a negative 20 over 36. All right, so our numerator is going to stay the same. We still have a negative 21 over 12. But my denominator, I'm now going to have to add these two together, or in this case, actually subtract. So if you're working with 36 as your denominator, remember, 1 is going to really end up being 36 over 36 to work with it a little bit easier. So this is going to end up being, I'm sorry, that shouldn't be negative. That should be positive. This is going to be a positive 16 over 36. All right, so I know from what we've seen right now, when we have these complex fractions, we're able to just cancel the denominators out. Be careful with this one because obviously the denominator of 12 and 36 aren't the same. So you can cancel, but you got to be really careful because in this case, the 36 is going to be a 3 because that's how like the 12 and 36 cancel because 12 goes into 36 3 times. So what you're really doing is you're really multiplying a negative 21 by 3 over 16. And when we do that, that ends up giving us that ends up giving us a negative 33 over 16. But don't forget, you're working with cotangent to start this problem. So once you're here, we have to flip it. We're still going to have a negative, but our answer should be a negative 16 over 33. All right, so as you guys go through this, please let me know if you have any questions. You can email me, comment through Google Classroom, any way you can reach me. I promise I'll get back to you guys. But please let me know if there's anything I can help with. More leading up to this quiz coming up on Monday. And I hope you guys have a good rest of your day. I'll see you.